Hello everyone. Welcome back to Dr. Liu's VCE Chemistry channel. Today, let's learn together about the 2024 VCE Chemistry examination. We will focus on questions related to equilibrium and rate of reaction. My explanations may need to be revised. If any teachers, parents, or students find errors, please feel free to provide your guidance. An exothermic reaction is not related to whether this reaction is reversible or irreversible. Also, the stability of products does not determine whether this reaction is reversible or irreversible. Suppose the rate of the reverse reaction is so slow that it can be ignored. In that case, a reverse reaction does not occur in practice, and this reaction is irreversible. Whether oxygen is limited or unlimited does not push forward or backward reaction. A catalyst does not change the enthalpy of reaction, but increases the activation energy. Therefore, adding the catalyst neither increases the energy of the reaction nor changes this exothermic reaction into endothermic. Suppose the catalyst is removed, the activation energy should be increased and rate of the reaction slowed. This reaction is endothermic, so the higher temperature pushes forward the reaction. The number of particles on the left side is less than on the right side, so lower pressure favors forward reaction. Of these four options, option C has the lowest pressure and highest temperature, so it gives the greatest yield of nitrogen dioxide. Sulfur trioxide is placed in an empty container, which is then sealed. So, no sulfur dioxide and oxygen are in this container, and they do not escape from the container. Please read the chemical equation of this reaction. If 1 mole of oxygen is produced, 2 moles of sulfur dioxide must be produced. So, option D is correct. Furthermore, the molecular mass of sulfur dioxide is 2 times that of oxygen, and the mole of sulfur dioxide is twice that of oxygen. So, option A is also correct. A few drops of sodium thiocyanate solution cannot increase the volume of the solution, but it increases the concentration of thiocyanate ions. When the concentration of thiocyanate ions increases, the rate of forward reaction increases so that the rate of the forward is faster than that of the backward. Since this reaction is pushed forward, the concentration of Fe3+ ions at time 4 is less than that at time 1. Either the equilibrium is independent of the concentration of reactants and products, or chemistry energy. All reactants and products are gas. The partial pressure is proportional to concentration. Therefore, the equilibrium constant of this reaction could be expressed as partial pressure. The concentration is replaced by partial pressure, and the Kp, the equilibrium constant of partial pressure, is written. Please compare the Kc with Kp. The target is partial pressure. We substitute the value of partial pressure into the equation and solve the partial pressure of ammonia. Some factors shift the system from equilibrium to non-equilibrium. The reaction quotient of the new state is less than the equilibrium constant. Removal of product, addition of reactant, or reduction in volume could decrease the Q. When the Q decreases, the reaction could move forward. Finally, the system will restore the equilibrium so that the reaction quotient is equal to the equilibrium constant. Ion catalyst addresses the conflict between optimal rate and temperature considerations in the production of ammonia. Ask the student to refer to the green chemistry principle to answer this question. The answer should link logically the catalyst to conflict and green chemical conceptions. Due to the exothermic nature of the equilibrium, at high temperatures, the rate of formation of ammonia is high, but the yield will be low, whereas at low temperatures, the rate of formation of ammonia is too slow, but the yield is very high. The catalyst decreases the active energy so that the reaction can occur at a sufficiently fast rate at a low temperature, and the catalyst reduces the energy requirements. Catalysts lead to lower energy consumption and fewer reagents in this process. Lucia investigated bioethanol production from the fermentation of glucose solution in the presence of yeast. Enzymes in yeast assist with the fermentation reaction. Lucia trialed two methods for the investigation, Method A and Method B. Both methods were trialed once. Method A measures the decrease in mass of gas, and Method B the increase in volume of gas. In the fermentation reaction, 1 glucose produces 2 ethanol and 2 carbon dioxide. High temperature will denature the enzyme. Please note that students do not refer to safety considerations in their answers. The gas produced is carbon dioxide. First, calculate the change of mass of carbon dioxide, and then calculate the mole of carbon dioxide. First, calculate the volume of carbon dioxide, and then this volume is divided by mole volume at SLC to get mole of carbon dioxide. State an assumption on which the calculation in the previous question is based. The gas collected behaves as an ideal gas. Carbon dioxide does not react with or dissolve in water, so all carbon dioxide produced ends up as gas in the burette. The gas collected in the burette is 25 degrees Celsius. The gas collected in the burette is 100 kilopascals. The only gas present in the burette is carbon dioxide. Compare the resolution of the data in Method A and Method B. In Method A, the resolution of the balance was 0.1 G. In Method B, the resolution of the burette must have been 0.1 milliliters. The change of volume measured in Method B is larger than that in A. Lucia hypothesized that the rate of the reaction would increase as the concentration of glucose solution increased. So, the independent variable is the concentration of the glucose solution. Lucia hypothesized that the rate of the reaction would increase as the concentration of glucose solution increased. This hypothesis is not supported by the data. The rate of reaction is equal to the slope of the lines. Two lines have the same slope before 15 minutes. Therefore, the higher glucose concentration has the same rate as the low concentration. Identify one limitation of Method B. This limitation should be different to answer in Part B3. The gas may dissolve in the water as it bubbles through. The collected gas pressure may not be the same as the atmospheric pressure. Some gas may escape before the stopper is applied. Not all gas was collected in the burette. There may be difficulty in setting up the complex arrangement. The gas temperature is not at 25 degrees Celsius. The burette cannot collect the 500 milliliters of gas shown forming in the graph. The discussion is where the limitation should be identified. In equilibrium and rate of reaction, 5 multiple-choice questions are awarded 5 marks, and 2 short-answer questions are worth 20 marks. The overall score for this section is 25 marks. With a total possible score of 120 points, the percentage for this section was 20.8% of the total score. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.